So Rutherford gave the explanation about his model, and along with that, he discovered positive charge center of atom, which is called nucleus. All right. So you can measure the radius of nucleus and radius of atom. They are a big difference. Let me give you an idea. All right. Imagine a cricket stadium or a football stadium. Imagine a football stadium if you are a football lover. Imagine a cricket stadium if you are cricket lover. All right. And imagine the complete earth. So the stadium, the size of the stadium is the size of nucleus, and the size of earth is the size of atom. Did you get an idea? So atom is way bigger than nucleus. So nucleus is very small region, and if you want to get an technical answer, let me tell you, if we take radius of nucleus 10 to the power minus 15 meter, radius of atom is radius of atom is 10 to the power minus 10 meter. All right. If you take a ratio, then radius of atom upon radius of nucleus 10 to the power minus 10 upon 10 to the power minus 15, 10 to the power minus 15, you take this, then you get 10 to the power 5. That means radius of atom is 10 to the power 5 times, radius of atom is 10 to the power 5 times radius of nucleus. Alright, that is 1 lakh times radius of nucleus. Radius of atom is 1 lakh times, 1 lakh times radius of nucleus. So there is a big difference in the size of nucleus and size of atom. Alright. In this page, we have discussed the ratio of, if you take a ratio of a radius, same way you can take a ratio of diameters. Diameters of atom upon diameter of nucleus, that will also come out like 10 to the power 5 times. And same way, if you put a volume ratio, volume of atom, what you have to visualize is, atom is a spherical thing, so volume of a sphere is 4 by 3 pi r cube. And same way, volume of a nucleus will also be 4 by 3 pi r cube. So you can put a ratio thing over there, and you can completely get a volume ratio. If a radius ratio is coming out to be 10 to the power 5, volume ratio will come out cube of it. Okay. So that will be 10 to the power 15 times. Radius of atom is 10 to the power 5 times radius of nucleus. Same way, volume of atom will be 10 to the power 15 times volume of nucleus. Alright. So that is what we are explaining over here. And the other thing is, what is drawback of Rutherford? Is everything fine about Rutherford? No, absolutely not. J.J. Thomson had a problem with his model, that he explained that everything, the positive sphere and the electron were embedded in it. Then Rutherford did a alpha scattering experiment, and he said, no, atom is not a solid sphere, atom is a vacant or an empty space, and at the center positive nucleus is there, right? Then few people came across, scientists put a question mark on his model, and that is what we are calling that drawback. According to his model, everything should have been fine, but that was not absolutely true. What was the drawback? Let me explain it to you. He told electron is revolving around the nucleus. Alright. There were classical electromagnetic theories which told, if a charged particle, let's say electron, was revolving around the nucleus, that is again a positive charged particle, so there must be attractive force. Then charged particle electron will accelerate and it will emit electromagnetic radiations. Alright. Just listen to me. Electron will emit electromagnetic radiation. That means it will emit energy. So if initially electron was started from here, it will take a bigger circle, then it will emit energy, it will take a smaller circle, and finally it will collapse inside the nucleus. So what do you get? What? Electron is getting collapsed into the nucleus. That means atom is getting destroyed. But atom is completely stable thing. But according to Rutherford theory, atom is not stable. So that was the drawback. Rutherford could not explain the stability of atom. So that was the drawback. Rutherford's model was not accepted on the whole, and we had to address to this drawback. The drawback of stability of atom was there in the Rutherford model, which was later explained by Bohr's atomic model. So that's it for this page.